Try it again. Welcome back. Today we're going to look at using a number of list operations. So, what we're going to look at today are the following. Actually, before I do that, if any of you are interested in joining the computer club we're setting up, you're working in the hackerspace, we use Raspberry Pis at the hackerspace, which employ Python. So you'll be able to use your Python and they have a bunch of them there, so you can just use the ones that they have. And so you can go there and do little robotic projects and control projects with the Python you learn over at the hackerspace. If you put your name there, I'll add it. And Bruce Carey is kind of lead of that part of the computer club, and that way we send out things periodically and let you know when things are going on. So we're going to talk about common sequence operations, indexing, slicing, adding sequences, and multiplication of sequences. Sequences are a powerful thing that Python has. A lot of these things allow us to use Python very, very quickly. So if I was going to do some of these operations in C++, I'd be writing about 5 or 6 lines of code. We can often, with Python, just write a little short expression, and it'll iterate through a whole list and morph and merge and modify them together. And so it's kind of a really cool capability. So common sequence operations. So we're going to describe what common sequence operations are first. And their data structures. Basically, anything that's a collection of data elements, basically lists. You can have lists of numbers, characters, other data structures. So you can actually have a list of data structures which are in turn each a list of something else. So you can nest all these structures together, and you can list all these lists at multiple layers of hierarchies. We'll kind of see what that means in a bit. And so the sequence is the most basic data structure in Python. Each element of a sequence is assigned a number, and that number represents the elements at that position. We call that number an index. So if you think about it, I have a list of names. I will have a name at index 0, which will be the first one, a name at index 1, which will be the second one. All the indices start at 0. The third name will be at index 2, and so on and so forth. We can use that index number to specify, for example, a print statement, which element of that sequence we want to work with or to list. So there are 6 types of sequences in Python. And we're kind of going through and defining these terms because these terms have specific meanings, and they help us make sure that we're talking about the right thing. So these are sequences. Lists are a type of sequence. Tuples are a type of sequence. The string, for example, when we brought in that user input with this raw input, what comes in is actually a sequence of characters. And it's treated as a sequence of characters called a string in Python. We have Unicode strings. There's 2 types of characters, ways of representing characters in computers. We can use ASCII codes, which have 256 different characters you can represent with that. And there's Unicode, which has, I think, over 1 million. And Unicode is often used today because that way we can localize to multiple languages. And that allows us to represent languages like Chinese and Korean and Russian, which have different characters. So that's what a Unicode string is about. Buffer object and X-range objects. We are going to focus on lists and tuples. And then also, we will use strings. So lists are sequences that can be changed, and you use it if you need to add elements after the list is created. A tuple is a list that once it's created, it can't be changed. You use it if you don't need to modify it later. So we say that tuples are basically immutable. That means it cannot be mutated, cannot be modified. And lists are mutable. And why don't we just always use lists? We could just choose not to change it. Well, but there's actually some performance advantages of using tuples. So if you don't need to modify it, it gets created once. you tend to want to use tuples. Make sense? These are just terms at this point. When we start writing code, it's going to make a little bit more sense. So, some common sequence operations include and so here we're going to demo some operations that are common to all sequences, including lists and tuples. But we're going to show it with lists and tuples, but they also work with strings. So you can actually get the index, for example, of which character you want in a string. So, which is going to be useful. So common sequence operations are indexing, slicing, adding, multiplying, and checking for membership. And we'll go over each one of these one by one. So let's open up idle, and at the within the shell part of idle where we have the command prompt, we're not going to make a program at this point. We're just going to type some stuff in and play with it. Type greeting equals single quote, hello, close single quote. And then type greeting, open square brace, these are square braces here, 0 and close square brace, and tell me what you get. You get H. So 0 is all indices. When you use indexes in a computer programming, typically 0 is the first element, which works well for the computer because that's a sequence of all 0 bits. But of course, with the human beings, if you ask someone to please pick an element, there's very few people out there that are going to say, I would like the 0th element, please. So often when we ask someone for input, we ask them for which element they want. They say they want the first one. We subtract 1 to get the index. And so this will display H because H is the first letter in hello, and 0 indicates that I want the first element. And you can play around, put greeting of 3 or greeting of 2 and see what happens, and you'll see that you'll get the element that corresponds to that index. Make sense? So that can be useful. You could eventually, when we learn to iterate, we could iterate through here and look for a particular letter. Or you could see which of these names starts with the letter H. So that's what indexing is used to get a particular element. Now type greeting of -1. So realize you've already assigned hello into greeting. That's a variable that's holding the word hello, or the string hello, in memory for you, and so you can keep working on it. And so if you type greeting of -1, what do you get? You get the O. So what do you think it's doing with the -1? It's going backwards. Python tries to make every possible thing you enter do something useful so that then you don't have to do error checking, right? If someone put a -1 and you couldn't, in the language didn't handle -1, it could just throw an error. But it's much more useful for it to say, oh, let's just say that the negative number starts from the end and works its way backwards. And so if you put -2, you would get L, -4 would get the E, etc.
It'd be useful for really long line of code, right? Like long.
Yes, and like if I do this in C++, I have to get the length of the word, and then subtract 1 from that, and then use that as the index to get that element in that array. And so I'm at 3 lines of code, and here they said, people want to do this, so we have it kind of just right there. So negative indices count from the end of the sequence backwards. Now type hello and put -1. So this looks kind of weird, right? It makes sense from a variable. You put the square brace. What happens if you put a thing there and then you put this index thing? What do you get? Oh, yeah. So a lot of times with Python, you can actually, if it works with a variable, it'll work with the thing itself as well. Yeah. And so it says, okay, hello is a sequence. I need the -1th element of that. That'll be the 0, and it just works as well. So you can do, this is probably unlikely that you'll see this that much if you think about it. I could just write O for that, right? It does Mostly, I'm probably going to bring something into a variable like someone's, an input from somebody, and then I'm going to apply an index. But it just kind of shows you that Python is very flexible about kind of reading through and interpreting stuff.
Way better than writing just no.
Is that?
And way better than writing just no.
Yeah, well, I mean, it's convoluted.
I did it.
So try this. Say fourth equals raw input, and the prompt we're asking the user is the year, and then we put an index here, 3. What do we think this is going to do?
Give you a third character of whatever year.
Yeah. If you type in, for example, 2005, and then you say display fourth will contain the 5. So what happened is we did a raw input. It prompted us for the year. We type in 2005. It stores, because of this 3 here, what it's going to do is it's not going to store the whole input. It's just going to grab the 5th element. And it's going to grab the 4th element, because remember it's 0 index. So 0 would be 2, 1 would be 0, 3 would be 0. 0 would be 2, 1 would be 0, 2 would be 0, 3 is the 5th. So this corresponds to this 5 here. And so when we say, show me what's in 4th, it's just that 5th character, that 5, the 3rd character, or the 4th character. I butchered that a little bit. Does that make sense? So we can see here what we did is we did a raw input. It got the whole input from the user at that point. But then when we did this index, the only thing it threw into 4th was the element at index 3, which is that one. And is this really a great way of doing this? Probably not, but it kind of shows you. But maybe you're getting input from something, and you know that you can ignore a certain number of characters. You only need that last one. Potentially that's good because I want to just store the end part of the year. So let's open up on listing 2.1. Let me grab that for you real quick. I forgot that we had a listing on this one. And I don't have it here. Presentations. Let's see what I